Okay, chapter 5, section 2 is about writing out chemical reactions, showing the chemical equation and what does everything mean within it. So when we write out a chemical equation, it's a shorthand, an easier way than writing out all the names or words. So a formula is the word that represents the compound. So for example, water or hydrogen dihydrogen monoxide, we would write out as H2O. The formula shows the ratio of the atoms that make up the compound. So it takes 2 hydrogens for every 1 oxygen to create water. That subscript, the 2 after the H, tells us the number of atoms we need of hydrogen to combine with the number of oxygens. There's no subscript, so that O means 1. So 2 hydrogens for every 1 oxygen. Now the equation summarizes the reaction. And when we have an equation, you have a beginning, the arrow sign, and then the end. The reactants are the materials you're using at the beginning of the reaction. The products are what you come up with at the end of the reaction. That arrow means equal or yields, just like an equal sign in math when you add or subtract or multiply or divide. So a chemical equation is going to use symbols to show the reactants and the products. Now, there's a law of conservation of mass, or what's known as the principle of conservation of mass, that says no matter how many reactants and products you have, whatever your total mass is for the reactants, you must have that same amount of mass at the end in your products. It doesn't mean they're going to end up in the same way, but when they get rearranged into new compounds or new elements showing up as the products, it still has to have the same amount of mass. You can't lose anything. You can't somehow gain extra. It must always equal. So when we balance equations, we're going to look at the reactant side and we're going to compare it to the product side. So the number of atoms of hydrogen on the reactant side is 2 because we have that little subscript H on the reactant side. Remember, that's the left side. The number of atoms of hydrogen on the product side is 2 because you have that little 2 after the H in H2O. If you look at the number of atoms of oxygen on the reactant side, we have 2 because there's that subscript. But if you notice on the product side, we only have 1 because we have the symbol O. So this is not balanced. What we need to do is show a balanced equation. We need to use something called a coefficient. A coefficient is a number that goes in front of the whole compound, and then everything within that compound multiplies by that number in front to get a total. And I'll show you on the next slide. So if you notice here, the very first example, we put a 2 in front of the H2, but we didn't put anything in front of the O2, and then we put a 2 in front of the H2O. So if I take that 2 subscript for the H, I multiply it by the 2, I get 4. So I have 4 hydrogens on the reactant side. I have 4 hydrogens on the product side. But on the product side, that 2 in front also multiplies against the O to show that there are 2 oxygens because we have 2 H2O groups. That balances the O2 on the reactant side. The same thing happens with the 2 with the Mg and the 2 with the MgO. You notice in the third one, the only thing that needed to be balanced was the chlorine. Now, oxygen and chlorine are written as O2 and Cl2 because they are diatomic molecules. Anything that is a gas or liquid at room temperature must be written as a diatomic molecule. So that 2 times 2 for the chlorine multiplies to 4, which balances the 4 for the subscript in carbon tetrachloride. On the last example, you notice each one has a different number because each element has to be balanced on the reactant and product side. So 2 times 2 gives me 4 for the Al2O3 for the aluminum. 2 times 3 gives me 6 oxygens. So on the product side, I needed to put a 3 in front of the O2 to give me 6 oxygens, and 4 in front of the Al because the Al represented 1. All right, there are 3 main categories of chemical reactions: synthesis, decomposition, and replacement. And I will go through each one. Synthesis is when elements or compounds combine to make something more complex. So when we take hydrogen gas and oxygen gas and combine them together to make water, water is more complex than the individual gases. So you combine, you have multiple reactants to make a single product. Decomposition is the opposite or the reverse. So like that last example I had with aluminum oxide, breaking down into aluminum and oxygen, you have one single reactant that's going to break down into simpler products. Replacement is when an element replaces another element. So you have a single element and then it replaces an element within a compound, or you have two compounds and the cations switch places to make two different compounds. All right, let's go through the review questions. Reactants and products are written out to form the chemical equation. For question 2, the principle of conservation of mass, or that law of conservation of mass, says that the total mass of the reactants must equal the total mass of the products. Question 3 wanted to know what the three categories of chemical reactions are, and that's your synthesis, decomposition, and replacement. Question 4 wanted to know how you would balance each of those equations. And the first one was balance, which really threw some people off. Question 2 there, that B, you needed to put a 2 in front of the iron oxide, a 3 in front of the carbon, 4 in front of the iron, and then a 3 in front of the carbon dioxide. Okay, now I want you to notice that B is a replacement equation, okay, because the carbon and the iron switch places. C, you have sulfur dioxide and oxygen combining together to create sulfur trioxide. All right, and that first one was the decomposition. All right,